So we're in section 1.4, and we're talking about measuring angles. So before we talk about measuring angles, I just really quickly want to review some vocabulary about angles. This should be, the vocabulary should be on your vocabulary sheet that we did, but just to recap, just to reinforce, an angle is two rays with the same endpoint. So if I draw a picture of an angle the way we think of an angle, here are my two rays, and here's my endpoint that's the same. I'll call that point A. We'll say this ray goes through point B, and this ray goes through point C. What did we call this point? Point A, the point that they share is the vertex. What did we call the rays that make up the angle? Those are the sides of the angle. So that's a side, that's a side. Inside here is called the interior. Just makes sense. Outside here is the exterior. And we call this angle, we're going to name this angle. What's a symbol that we use to name an angle? Yeah? The little angle. So what's one way we could name this angle? BAC. Angle CAB. Angle A. All three of those. What if I had a little number 3 in here? Yeah? We could call that angle 3. All 4 of those would be fine ways to measure or to name that angle. All right, we're good with our vocabulary there. All right, so we measure angles with a protractor. And a protractor really is just a curved ruler. We use a protractor just like we use a ruler, except the protractors are curved. What unit do we usually use for angles to measure them? Degrees. Usually use degrees. When you get to pre-calc, you'll use something, a different way to measure them. But we use degrees. And we write little m for measure of angle A. So what we would say is measure of angle A when we saw that. The little m means measure, and m measure is talking about the degrees. All right, so let me demonstrate measuring some angles. So I'm just drawing some angles. I grab my protractor, 180-degree protractor. Just a reminder about using a protractor. Your protractor is going to have an X or a dot or a cross, or some have a little hole right here in the middle at the bottom. That's where you put the vertex of your angle. And then you line up one side of the protractor with one of the rays on the angle. So I line up the line there on the protractor with that one ray, and I go over here to the scale, and I'm looking at the inside scale because my angle is less than 90 degrees, and it looks like I drew a 60-degree angle. So if this is angle A, I would say the measure of angle A is 60 degrees. And if we have a bigger angle, so let me draw this angle. Oh, let me undo that. I want to make it a little bigger, like so. And I'll call this angle B. Do the same thing. Put the X or the cross or the dot or whatever on your vertex. Line up the line here at the bottom with one of the rays. And then this time I'm going to go over and read on the bigger numbers because this angle is bigger than 90 degrees. And it looks like I have about 126 degrees. So 120 would be here. There's 125, 126. So I'd say the measure of angle B is 126 degrees. Now if my angle is turned the other direction, so if I had an angle opening to the left instead of to the right, do the same thing. Put the dot or the X or the whatever your marker is, line up one ray, and I'm going to read this on the scale where the numbers are smaller than 90 degrees because this angle is smaller than 90 degrees. So it looks like I have about a 46 degree angle or so. That would be pretty close. So if this is angle C, I'd say the measure of angle C is 46 degrees. Now what if you're measuring an angle that's in your textbook or something and it's tiny? And I put my protractor on there and I line it up, but I can't tell, is this exactly 70 degrees? Is it a little more? Is it a little less? So if we can't tell for sure, what can we do? We could guess. That's always a possibility. But do rays stop? No? Yeah, they keep going. So we could just put a ruler on there and make that ray longer. I could put a ruler on there and make that ray longer so it's easier to see on my protractor. And if you have a bigger protractor like this one, sometimes you have to make those rays pretty long to reach out to the scale. So now I look at this ray, or this angle, and it looks to me like it's about 68 degrees. Close to 70, but not quite. About 68 is what I would say. Get rid of that. I'd say if this is angle D, measure of angle D is 68 degrees. So that's how we go about measuring angles using a protractor. All right, questions there. All right. Important types of angles. I think we know these already, so this is probably going to be a review. What is a right angle? Yeah? 90 degrees. And the way that we see a right angle, that we mark a right angle in a figure, is there's my angle. Put a little square in the corner. That would mean that angle is a 90-degree angle. A straight angle. So what do we mean by, let me undo that. What do we mean by a straight angle? is basically a straight line. How many degrees would that be? What is it? 180. Straight angle is 180 degrees. And a straight angle really just looks like a line. So there would be my angle. This would be the vertex. I could say that's 180 degrees. The other way that you hear straight angle referred to is opposite rays. Opposite rays make a straight angle. Yeah. I think it does ask you to measure some angles on your homework. Acute. What is an acute angle? Yeah.
Angle of 45 degrees.
A 45-degree angle is an acute angle, but is that the only acute angle? Less than 90 degrees? Okay. How about negative angles? Would a negative 200-degree angle be acute? Yeah.
It's an angle between 0 and 90 degrees.
Between 0 and 90. And an acute angle, we usually think of acute angles being small angles, like that. How about obtuse? An obtuse angle, yeah?
Between 90 degrees and 180.
Between 90 and 180, nice. And an obtuse angle we usually think of as kind of a big angle. Did I say obtuse? That should be obtuse. All right, so those are our special angles. We'll talk about acute angles, obtuse angles. Straight angles don't show up that much. They do show up sometimes. Right angles we'll talk about a lot. All right, so we're good with our special angles. We'll talk about special angle pairs tomorrow. All right, the next thing we need to talk about is about congruent angles. We use congruent with angles exactly like we do for segments. So if we say two angles are congruent, we're saying they're the same size and two angles angles are the same shape. What is the same about them other than their size and shape if two angles are congruent? Did you have an idea? No? How do we measure angles? What do we use to measure angles? Protractor, and the protractor measures degrees. So if we say two angles are congruent, what are we saying? They have the same number of degrees. Congruent angles have the same number of degrees. So just like congruent segments would have the same number of inches or centimeters or some measurement of length. And we use tick marks just like we do for segments. So if I have two angles, angle A and angle B, and I want to say those are the same or congruent, I have a little arc there, and I would put the same number of tick marks there. So since A and B both have the same number of tick marks, I would say angle A is congruent to, the equal with a squiggle over the top, angle B. The other way I could say it is the measure of angle A, the number of degrees, equals the measure of angle B. These two things mean the same thing. The other way you'll see this marked in figures, sometimes in our book, they'll use the same number of arcs. So if we wanted to say angle C is congruent to angle D, sometimes in our book they'll mark them. If angle C has 2 arcs and angle D has 2 arcs, we would say angle C is congruent to angle D. Angles that had 3 arcs, all the angles that had 3 arcs would be congruent, etc., etc. All right, questions about congruent angles. The idea is exactly like for segments. All right, we just have one postulate to talk about today. The angle addition postulate. Let's remember what a postulate is. Talk about postulates all year long. Someone remind us what a postulate is? Something, yeah?
We can't prove, but it's still true.
We accept it as true even though we can't prove it. Angle addition postulate tells us the same thing as the segment addition postulate. I'm adding 2 small pieces to get a bigger piece. We have angle AOC. Point B is in the interior. Of the angle AOC. When that happens, the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. In words, it sounds a little more confusing than it really is. So let's draw a picture. There's my angle AOC. So O is my vertex. There's point A. There's point C. And point B is in the interior. So there's point B. So what we're going to do is draw a ray from the vertex through point B. And what the problem tells us is this small angle, AOB, that's this one, plus the measure of the other small angle, BOC, equals the measure of the whole big angle, AOC. We're adding 2 smaller angles together to get the big angle, just like we did with segment addition. That's all the angle addition postulate is telling us. Add 2 small pieces, you get a bigger piece. All right, questions? Okay, I just want to do one example with the angle addition postulate, and then we'll be done. So here's my setup. Oops, undo, I wanted that blue. There's that. All right, so this big angle is angle ABC. We have D here, so D is in the interior of angle ABC. And it tells us that this angle is 6x minus 5. This angle is 4x plus 10. And the measure of angle ABC is 175. So this whole thing is 175 degrees. And the problem asks us to find the measure of angle ABD. and, that's a question mark, the measure of angle DBC. So what do we do here? What does the angle addition postulate tell us that we can do with these two things? Add them together, right? The two smaller pieces have to add up to what? The whole thing, 175. The two small pieces have to add up to the whole big thing. So I'm going to say 6x minus 5 plus 4x plus 10 equals 175. Two small pieces add together to give me the big piece, the whole big piece. Well, now we just have an algebra problem. Combine like terms, 6x and 4x is 10x, negative 5 plus 10 is plus 5. That equals 175. Subtract 5. 10x equals 170. Divide by 10. And x equals 17. Did the problem ask us to find x? No, we have to find those two angles. So what do? Plug it in, plug x in. So the measure of angle ABD is 6x minus 5, 6 times 17 minus 5. And that gives me, when I calculate that out, 97 degrees. The measure of angle DBC is 4 times 17 plus 10, which gives me 78. And what should those two add up to? They should add up to 175 if we did everything correctly. 97 plus 78 equal 175? Yes. So I'm going to say check. We did our problem correctly. Just a way to check our work. All right, questions? Okay. Homework. There's that. Any questions? Let me stop this. I don't need this anymore.